In this section, we're going to talk about coterminal and reference angles. And let's start with the definition. Coterminal angles are two angles in standard position that have the same terminal side. So in this example, we see 140 degrees and we see negative 220 degrees. 140 degrees ends in the second quadrant, and it starts at the positive x-axis going counterclockwise. Negative 220 degrees also starts at the positive x-axis, but it goes clockwise, and it ends also in the second quadrant. In fact, their initial sides and their terminal sides are the same. So, more specifics. Let theta equal the given angle. We can say that a coterminal angle is that angle, if we're in degrees, plus 360 degrees times k. Or, if we're in radians, that would be plus 2 pi k, where k is an integer. Now, this is fancy notation. This thing that looks like a z, that represents an integer. And what is an integer? An integer, let me write this down. An integer is the set of whole numbers, so 0, 1, 2, 3, ... no fractions, no decimals, and their opposite. So it would also be negative 1, negative 2, ... So what we're really saying here with this formula is that if we have a given angle, say 140 degrees, if I add to that 360 degrees times 1, then that's going to get me a coterminal angle. 140 degrees plus 360 degrees times 1 would be 500 degrees. All that says is if I go to 140 degrees and then I add a full rotation and go back to where I started, although they measure different spaces, they share the same terminal side. That makes them coterminal. Now, where the heck did negative 220 degrees come from? Well, that came from, instead of using an integer value of positive 1, we used an integer value of negative 1. So 140 degrees plus 360 degrees times negative 1 is the same thing as 140 degrees minus 360 degrees, and that's where the negative 220 degrees came from. Of course, if we're in radians, then we are dealing with 2 pi as our rotation. Now, because we can keep adding and subtracting over and over and over again, an angle has infinite many coterminal angles. Now, what's a reference angle? An angle's reference angle is the size of the smallest acute angle, which we're going to call T prime, formed by the terminal side of the angle T and the horizontal axis. Coterminal angles have the same reference angle, and reference angles are always positive. They're always positive. All right, let's take a look at an example. Sketch the angle 19 pi over 4, and then find a coterminal angle and the reference angle. So a coterminal angle tells you there could be more than one correct answer. Remember, there are infinite. And then there's one reference angle. All right, so first thing I want to do is identify where is 19 pi over 4. Well, we've talked about how if you are given something, say, in fourths, then one way of finding out where that angle measure is by counting in fourths. So, for example, I know that one full revolution around the circle is 2 pi, but in fourths, that is 8 pi over 4. right? So 1 full rotation is 8 pi over 4. If I do another revolution, that's going to be 16 pi over 4. And let's see, I can't go all the way around again, but I can go another 3 pi over 4. Puts me into the second quadrant. And that should be where 19 pi over 4 is. All right, so I'm going to say that 19 pi over 4 is in the second quadrant. One way of writing that would be to say that 19 pi over 4 is equal to 16 pi over 4 plus 3 pi over 4. And 16 pi over 4 is really 2 pi. It's 2 rotations, isn't it? So it's 2 pi times 2 plus 3 pi over 4. It represents, this would be the case where our k value was equal to 2. Okay? So there we go. A coterminal angle. Well, I think we could almost just look at this, couldn't we? What is a coterminal angle? To me, if you've got your circle memorized, you can say that probably 3 pi over 4 is coterminal with 19 pi over 4. But if you weren't, say, thinking logically and you just wanted to use the formula from the previous slide, we could say that if we take 19 pi over 4 and we add 1 complete rotation, so we're going to go around 1 more time, that's going to get us a coterminal angle. So again, we need to think in terms of fourths. 2 pi is 8 pi over 4. So if we add those, 19 plus 8 is 27 pi over 4. So 3 pi over 4 is coterminal. So is 27 pi over 4. I could just go crazy. I could keep on going. Could I have gotten the 3 pi over 4? Yeah, I think that if I had taken 19 pi over 4 and I added to that 2 pi times an integer value of -2, then I would have had 19 pi over 4 minus 4 pi, which is 19 pi over 4 minus 16 pi over 4, and there's the 3 pi over 4. So that would be another coterminal angle. Let's talk about the reference angle. The reference angle is the smallest acute angle between the terminal side and the horizontal axis. Okay, so the terminal side of this angle we said was in the second quadrant. The initial side, of course, if we're in standard position, is always going to be the positive x-axis. So the reference angle is the smallest acute angle between the terminal side and the horizontal axis. Not the positive horizontal axis, but just the horizontal axis. So that's going to be the space between the second quadrant and the x-axis, which is this distance. And so that distance, to me, looks like it's going to be pi over 4. So we're going to say that the reference angle is pi over 4. Now notice the reference angle of 19 pi over 4 is pi over 4, but also the reference angle of 3 pi over 4 is pi over 4. So coterminal angles share the same reference angle. And not only that, but because it represents a distance, then that distance is going to be positive, right? Distance is always positive.